Hello, friends. You're watching Nexus Innovate, and today we'll dive into the fascinating world of water computers, devices that use water instead of electricity for computing. Yes, you heard that right. These are real hydraulic computers, and we'll explain how they work and where they're still used today. What is a water computer? A water computer is a device that processes information using streams of water or other liquids. The principle is based on hydrodynamics. Water flows through channels and valves, while fluid pressure and flow direction act like 0 and 1 in a regular computer. Simply put, water instead of electricity, valves instead of microchips. History of water computers. Ancient examples: water clocks, clepsydras, the first hydraulic devices. Hero of Alexandria's automata, 1st century AD. Water and steam-powered moving mechanisms. Al-Jazari's castle clock, 12th century, complex hydraulic clocks and automata. Soviet developments. In 1936, Vladimir Lukyanov created a hydraulic integrator for solving differential equations. It was used in calculating concrete structures and remained in operation until the 1980s. How it works. Think of a water computer as a smart plumbing system. Main elements: channels and tubes. These are the wires. Instead of carrying electricity, they carry streams of water. Valves. These act like switches or gates. They decide where the water will flow, left, right, or stop completely. This is how logic operations, and or not, are performed. Water pressure. This represents binary signals, 0 and 1. For example, no pressure equals 0. Pressure present equals 1. Reservoirs. These are like memory. They hold water until it's needed again in a calculation. When you change the direction of flow, it's like the computer following an if-then rule. For example, water flows only if 2 valves are open, equals the AND operation. The speed and volume of the flow represent the rate of data transfer. The faster and larger the flow, the more information it carries. Everyday example: imagine a drip irrigation system. If you open one tap, only one garden bed gets water. That's like 1. If you open 2 taps, both beds get water. That's AND. If the tap is closed, that's 0. A water computer works the same way, only instead of watering plants, it performs logical operations. Modern research. Fluidics, the modern science of water and droplet-based computers. Sounds futuristic, right? But it's real. In 2015, Stanford scientists built a computer made of water droplets. And guess what? It could actually perform basic logical operations, just like an electronic computer, but with tiny drops of liquid. Applications? Medical devices that work inside the human body. Chemical analysis in the lab. And lab-on-a-chip microfluidics. Whole laboratories packed into a device smaller than your phone. Advantages of water computers. They can work in extreme conditions, radiation, high temperatures, you name it. They're biocompatible, safe to use inside living organisms. They don't create electromagnetic interference. And hey, cooling is built in. Natural water cooling, for free. Disadvantages? They're slower than electronic computers. They're bulky. And making them tiny, that's still a huge challenge. The future. Scientists are now working on nanoscale fluidic computers. Imagine computers smaller than a grain of sand. hybrid systems that combine electronics with hydraulics, and even biocomputers that work inside living cells. So yeah, water computers aren't just history, they're also the future. Conclusion. That's it, friends. Water can be not only the source of life, but also a tool for computation. If you enjoyed this video, give it a like, subscribe to Nexus Innovate, and share it with your friends. And in the comments, let us know, would you like to see a water computer in real life? See you in the next episode of How It Works on Nexus Innovate.